morning, student. Now in this experiment we are going to find out the convective heat transfer coefficient for force convection. Actually this setup is a combination of force and natural convection, so we are going to perform two practical on this setup. Now before going to the experiment, let's check what are the equipments and components are present inside it. So first one is nothing but the blower, which is an external equipment which forces the air inside the pipe. That's why this is an example of force convection. This air is passed through the pipe which have 28 mm inner diameter. This pipe is insulated with the help of some insulation so as to heat is not get leak in outside, so as to we get the value of convective heat transfer coefficient accurately. To measure the temperature inside the pipe, there are four thermocouple, that is T2, T3, T4 and T5. To measure the temperature of air, that is inlet air, we have first thermocouple, that is T1, and last thermocouple is nothing but the T6. So there are 6 thermocouple arranged in a axial direction. To give the supply or to generate the heat, we have a heater over here, and this heater provides the heat to the pipe at outer side. This heat will be transferred by the conduction to the inner side, and from the inner side of the pipe, this heat is get transferred to the air by the convection. To measure the flow rate of air, we have orifice meter over here. Across this orifice meter, we have two limb that is connected to the manometer, so as to we can take the difference, that is nothing but the head, and on behalf of this head we can find it out the velocity and mass flow rate for the air that we already discussed in manual. Now this is the control panel of force convection. In that, this is voltmeter, ammeter, this is temperature, digital temperature indicator, and this is nothing but the selector switch. Now here you have to be cautious because this is a combined setup, so you have to sure that this knob should be at a force side. If you want to perform the natural convection experiment, this knob should be at this side, that is nothing but the right side. Right now it is on a left side, right side. So here F is written, so this knob should be at a F side, that is force side. Blower should be off, but there should be a noise and voice is not clear, that's why I am right now keeping off. And this knob also on a force side. So for the force convection, this knob on a force side, this knob on F side, that is force, and blower should be on. And you have to use this knob to take the temperature. We have 6 thermocouples, so we have 6 temperatures. This total length of the setup is nothing but the 400 mm. So test length will be nothing but the 400 mm. Now we proceed for the procedure. As per our procedure, over here we written down, that is for the force convection we have to apply the voltage in between 90 to 100 volts. So I rotate this thermostat slowly and keep this voltage in between 80 to 100 or 90 to 100 volts. Once we fix the voltage, then we can't change it because we have to provide the constant heat flow rate. Now right now I am selecting 95 volts as a constant heat flux for my pipe. So at that time we have to keep it same for throughout your experimentation. So your first reading will be nothing but 94 volt. At that time current consumed by the experiment is nothing but 0.88 ampere. Now we have to take down the reading. So at that time blower should be on. So the first reading is an 32, second reading that is 30, third 30, fourth 30, fifth 29 and 6, that is 32. So there are 6 thermocouple and we take down the 6 temperature. Now here I off the blower, but you don't have to do like this, because during your experimentation you don't have to make your experiment dynamic, that is continuously on and off your blower. But just to get the clear voice, I am right now off the blower. Now you have to keep, or you have to take the reading after 5 minutes or 10 minute time of interval, and once you have a constant temperature reading, then you assume that that is your steady state and you can make the calculation.